Dr. Steve Fleming, who is a professor of cognitive neuroscience and a Wellcome Trust Royal Society Sir Henry Dale Fellow at the Department of Experimental Psychology here at UCL. His group's research focuses on mechanisms supporting human subjective experience and metacognition by employing a combination of psychophysics, brain imaging, and computational modeling. Dr. Maxine Sherman is also a professor of cognitive neuroscience and lecturer in computer science and AI at the University of Sussex. So she's come a long way to be here. Her research focuses on human metacognition as well, exploring how we assess our own and others' beliefs and intentions using behavioral experiments, computational models, and neuroimaging techniques. And finally, Dr. Haggard is also a professor of cognitive neuroscience. It's a trend here. Here at UCL. But his focus is on voluntary action, specifically in linking the subjective experience of intending and performing manual actions to the brain processes that occur before and after actual movement. To get a round of applause for our in case you don't know who I am, I'm just a second-year student studying psychology here at UCL, and I'll just be the moderator for today's discussion. Yeah. Okay, so I just want to start off, because metacognition and agency are huge words, right? I mean, what does that even mean? So maybe we could start off by distinguishing what exactly metacognition is, and perhaps the difference between metacognition and awareness, and then, if you're up for it, consciousness as well. Yeah. Let's start.
Shall I start?
Yeah, sure.
So, I mean, I guess we can give a straight definition of metacognition. I think you're right that it is a very broad term. So just like cognition is a very broad term, metacognition is essentially going up one level and referring to the set of processes that can evaluate and reflect on other cognitive processes. So it's not just one thing, it's a set of processes. You can decompose it. We can do experiments to try and pull apart the different moving parts that go into making a metacognitive judgment. But essentially it's taking cognition up one level. And I think one useful way of introducing metacognition is also to give some concrete examples. So you can, in the field of memory research, people are interested in how, for instance, a student revising for an upcoming exam, you might think to yourself, do I know this topic well enough or not? And that would be a metacognitive judgment about your current knowledge base. In a completely different domain, say the domain of perception that we often study in the lab, you might ask yourself, am I seeing the world clearly or not? Do I need a new pair of glasses? Is my visual system working as it should? And that's, again, a metacognitive judgment about a first-order process.
Yeah, so I guess to build on it, you can also think that it's basically repeating what you're already saying, is that you are the object of the inference or the decision. So unlike it being about the outside world, it's either processes about yourself or decisions, inferences about yourself. And a little bit like attention, it's kind of applied to other processes.
Is there a difference between metacognition and awareness, or rather the fact that we can be aware of a certain part of our cognition? Because I understand there is an unconscious aspect of metacognition as well, right?
It depends on who you talk to. So this is where it starts to slide into definitional semantic territory. I think it's useful to consider metacognition as distinct to consciousness. That you, as you say, just like you presumably can have unconscious cognitive processes, I think it's natural to think you might have unconscious metacognitive processes as well. So classic examples are things like error correction, which can take place unconsciously, or at least we think it probably can. But then, you know, there are people who want to reserve the term metacognition to refer to this more subjective, conscious self-evaluation. So then it just becomes a question of where people are relying on definition.
I mean, defining awareness is really, really difficult, and arguably much harder than talking about metacognition. So the advantage of talking about things in terms of metacognition, you can say I can report on it, I can reflect on it, I can think about it, I can tell you about it. And you don't have to get into this situation where you're trying to explain exactly what you mean
Yeah.
By being aware.
So when you refer to self-awareness, let's say in your photo, for example, it's kind of, you don't want to associate with the consciousness kind of.
Well, so then I think you've got a different word again, self-awareness. That I think is, so when I was trying to put together this terminology for the book that I was writing for a general audience, I was trying to put together this, this landscape of different, often overlapping terms. And the way I laid it out there, which is not the only way of laying it out, obviously, but the way I thought was useful was to consider self-awareness as being a conscious aspect of metacognition, essentially. Or that is part of what we mean by being self-aware. We are consciously aware of our behaviours, feelings, and so on.
Thanks for clarifying. And I guess just for clarity's sake, what's the difference between metacognition and the executive function in the brain? Are they the same system, or?
It is an executive function, I would say.
So it's one part of the executive function.
Well, so I think that I agree with Maxine that it is clearly a higher order thing. It's part of higher cognition, by definition.
What's it executing?
Well,
It's executive.
I would say it's quite distinct to classical executive functions in psychology that we think are supporting capacities such as fluid intelligence. And I think one nice way of showing that is both conceptually and empirically they can come apart. So you can engage in metacognition about your answer on a very complex reasoning problem. And you may well have got that right or wrong via applying various executive functions, which allow you to get a high IQ score, but you can reflect on that and self-assess whether you think you've got the answers right or wrong. That would be an aspect of metacognition. And then empirically, we see in large data sets, markers of fluid intelligence can be decorrelated from empirical markers of metacognition. So colloquially, you can have someone who's a very smart person, but doesn't have much self-awareness and vice versa.
Can you do the fluid intelligence task without metacognition?
I think you probably can. I think that's basically what ChatGPT is doing.
Doesn't do very well.
Well, the new ones do pretty well.
Okay, thank you for clarifying. Now over to you, Patrick. So, I guess you have the hard task of explaining to us what is meant by intent, and I guess the difference between internal and external agency, because those are two different things. And more importantly, how you set an empirical basis for that agency.
Right, so agency is easier to explain and to understand than intent. So intent is an important word, but it's linked to the debate about free will, which is complicated. And agency is less clearly linked to the debate about free will. So I'm actually going to start with agency, and then maybe we'll get on to intent. So agency is a tricky word because it's used in several different senses. So you can talk about a government agency which collects your taxes, and that's not what we mean here. But the core etymological root is the same word as action. So agency refers to actions. And it's really important to distinguish between sort of an objective physical use of the concept of agency and a subjective psychological use of the concept of agency. So it's an objective matter of fact whether somebody makes a particular action or not. So did somebody use that word? Did they call that person X, whatever X is? Did somebody pull the trigger? Did somebody commit a crime? So that's a matter which in principle is decidable. There are facts about whether the person pulled the trigger or whether they didn't, and it's the job of the legal system is sometimes to try to assess those facts. So there are facts of agency, and normally as psychologists we're interested not only in the facts of agency but in how we experience agency, and the phrase that's often used is sense of agency. So healthy adult humans, and possibly many other kinds of animals, have an experience of acting. And that's kind of not surprising because the action is a physical event and we have subjective experiences of lots of other physical events like the lights going on or the sound of the orchestra. We have we have an experience equally of what we ourselves are doing, and that's often called the sense of agency. So I think the sense of agency is sublinguistic. I think it's basically a sensory experience of which is rooted in the body. It's rooted in the fact that all of the actions that we make are actions that we express through our bodies. We only express our actions through our behavior, which means that there are motor commands that leave the cortex and go down to the spinal cord and cause our muscles to contract. So that is a set of physiological mechanisms which are packed full of sensors. So we have lots of sensory information about our own actions. But it's sometimes convenient to express agency linguistically, even though it's not a linguistic phenomenon, it's a sensory motor phenomenon. And the way to capture sense of agency in language is with the proposition, I did that. So if I say, I did that, then I'm attributing agency to myself. I'm presumably, unless I'm lying, I'm announcing the fact that I have a sense of agency over whatever that is. And the fact that I switched the lights on, I did that. So sense of agency then is, the definition that I've often given in papers is that the subjective experience of controlling one's own actions and through them events in the outside world. So you asked about internal agency and external agency. I hope what you mean is agency over the movements of my own body versus agency over external events. And this is really interesting because I think from the brain's point of view, there's probably not that much difference. So my own body is just a tool that I'm really, really used to using because I've always had it and it's quite familiar and I can make it move, but I could also make other things move. So for example, I could make you move by pushing you. And I could have agency over the fact that you would fall down. And from a brain point of view, I'm not sure that the distinction is really fundamental, but it's certainly familiar. So whenever we make anything happen, we make it happen through the immediate control of our own bodily actions, and then with our bodily actions, we can change the external world. So that is important because the human capacity to change the external world seems to far exceed the capacity of any other animal. Other animals change their world as well, but nowhere near as much as we do. And as social animals, it's really important because you might not care a lot about what I think, but you probably should care a lot about the way that I might influence the world around you and thus affect your kind of quality of life.
So traditionally, how would you operationalize the, well, let's say, sense of agency? So, yeah, I know you've done some work on let's say, action potentials, and then the feeling of intent follows.
So the sense of agency is a subjective experience, and our job, I guess what we're paid for, is to try to talk clearly about subjective experiences, to try to study the mind scientifically, and of course that's quite hard. So sense of agency proves to be quite an elusive experience. There's not much really clear scientific work on it, and I think probably the reason is that it's just so much part of the background of our mental life that we can never really isolate it and describe what it is. So if you ask about what is the subjective experience of colour, it's kind of fairly clear how you do the experiment. So you would have some stimuli that were just grayscale, and you'd have some other stimuli which had some, HSV or RGB values, some sort of dimensions of light wavelength. variation, and you would ask people to report their subjective experience when they look at grayscale stimuli, and you ask people to report their subjective experience when they look at the coloured stimuli. And what's really tricky is to know how to make the same sort of contrast in the case of the sense of agency, because we all have this constant experience of fluently controlling what we do and making our bodies move for us, and I'm trying to say something coherent, and then my speech articulators start moving and all this sound comes out, and I'm not even really thinking perhaps as hard as I should about what I say. And the agency is like a buzz. It's just always there. It's a constant backdrop to mental life. So it proves to be rather hard to study the sense of agency in a really clear and well-contrasted scientific way. As a result, what most of the literature has done is to study explicit judgments of agency. So do you remember I said that agency corresponds to the proposition, I did that? So it's relatively easy to do experiments where, for example, I don't know, you're moving the mouse on the computer screen and something pops up on the computer screen, and the question is, did you make that pop up, or was there some other cause? That's basically the way that psychologists intend to tackle the problem. The fact is that we very rarely make explicit judgments of agency. It's very rare that you have to explicitly judge, did I do that? Did she do that? Who did that? It's only really in courts of law that you make explicit agency judgments, but it's perhaps the simplest way into doing subtractive contrastive experiments on it.
So would you say that the thing that we're really trying to measure is the action potentials that come from the brain, and then we try to see at what point our subjective sense of agency kind of correlates with that brain activity?
Yeah, so I think, I can only talk about my own interests. So my own interests are in subjective experience. So I think we have subjective experience. I think it's kind of important and quite interesting. And I think it's a property of the brain. I think we have subjective experience because we have brains. I think subjective experience is a consequence of brain function, but we don't quite know which functions. And we don't quite know what exactly are the brain events that lead me, for example, to feel in control of my own actions rather than not. We know that there must be some specific mechanism, because we can see in cases of pathology, you get a few, fortunately relatively few, cases which are, I think, extremely distressing as far as one can gather, where people don't have the normal sense of control over their own actions. So either they make actions without feeling that they are in control of them, or they try to control actions but nothing comes out. And both these kinds of hypoagentic and hyperagentic sorts of neuropsychiatric disorders are really, really distressing. And they suggest that there must be a mechanism in the brain which somehow keeps track of what your actions are doing and sort of maybe tags them or underlines them or gives them a little highlight to say, yeah, Patrick, that's you.
So I've heard you mention before that the feeling of intention may...
Natural intention.
Sorry,
I
I'm
think I was asking questions about
Sorry,
I think that would be really
agency
interesting.
is a better word to use.
No.
Yeah, so I've heard you before that people have the subjective experience of agency, and that may be generated after the premotor command signal reaches a certain threshold. Could you unpack this for us?
Yeah, so there's a big argument in the psychology of agency about whether our sense of agency, our feeling of being in control of what we do, whether that's like more like a perception or whether it's more like an inference. So if it's like a perception, you would imagine a model where as your brain assembles the motor commands to control your actions, so as your brain puts together all the instructions, for example, to get your finger onto the light switch if it's dark and you want to switch the lights on, as your brain's making up all of that information, all those motor programs, you're already generating an experience of, oh, I'm going to switch the light on, I'm reaching out, and you're sort of prospectively producing an experience of being in control of the action that you make. That would be a sort of sensation-like or sensory motor-like theory of sense of agency. But there are lots of people who say that our sense of agency is just a post-hoc reconstruction that we make after the event. And the way that this works is that I notice the lights go on, I feel that my hand is on the light switch, and I say to myself, oh, Patrick, that must have been you who did that. Don't be frightened. That was what you expected to happen, wasn't it? So you reconstruct a narrative to describe all the things that you find you have done. And at that point, your sense of agency becomes more like a confabulation. It becomes more like your sort of the way you lay down your story of what you think you're doing in your life. And there's a slight implication behind that theory that you don't actually have any idea what you're doing in your life. It's all this stuff that happens to you, and you have to make up a narrative to stop yourself from being surprised by all the stupid things you do. But it's all post hoc and it's all reconstructed. And there's no doubt that the brain does this kind of post hoc reconstruction. That's clear. But the current feeling in a lot of sense of agency research inspired by social psychology in particular is that that's all that happens, is that our description of ourselves as being in control is just a story. It's a trick of the mind that's made up to retrospectively make sense of all the stuff that happens, and that actually we're not in control at all. So it's a very, very different view from the sort of fluency view that we feel control as we fluently execute our actions. And a lot depends on it sort of politically and morally about which theory you believe.
Is there a stance that you take, or
I'm always very careful about that. I think both. There's an element of interesting scientific truth in both theories. I think the current view that the sense of agency is just a trick of the mind, and that our illusion of being in control is no more than an illusion. I think that's a bit problematic. Because I think we do know what we're about to do. I think we do have a genuine subjective experience of what we're doing as we're doing it, or very, very slightly before. Why we have that experience or what we do about it is a completely separate question.
okay, I'm going to get off your back for a minute and ask an equally difficult question, which is, do you have any preconceived notions about the free will debate as of now? Just real quick, what are your hunches, I guess? Maybe like a one sentence.
Do you mean the debate that happened?
Yeah, about the post-hoc reconstruction.
Yes. Yeah, I mean, no, I also find both accounts plausible. I wonder whether it's reflecting an informational contribution to these judgments. This may be a question for Patrick, but whether is there room for both kind of processes, because you actually learn a bit more after the fact. Once you've actually completed, you could get knocked off course just before you hit the light switch. So I guess I'm quite interested in broadly Bayesian and inferential accounts and how the mind works. It doesn't necessarily mean we're literally doing Bayes in our heads, but it provides a useful framework for the idea that Maxine mentioned about self-evaluation being an inference. We're trying to collect information about ourselves, acting in the world, and how the cognitive processes, how internal, mental and bodily processes contribute to how we're going about what we're doing in the world. And I find that view attractive for various reasons. But I think it does start to provide quite a powerful account of various aspects of self-evaluation, including judgments of whether or not we're in control.
This is something I wanted to bring up as well, because I saw a paper that you wrote about the second order model of decision making. Could you unpack that for us, and how it's different from the first order of the post-directional, I think is what it's called.
Yeah, so this builds nicely on what I was just saying about Bayesian accounts. So the idea behind that model that we outlined a few years ago is that metacognitive judgments about whether you are performing well or badly on a particular task are inferential in nature, so you don't have direct access to how you're performing. The idea is that you build a model of how you're performing in any given setting, and that there's an interestingly parallel debate in the metacognition literature between people who think people who propose that feelings of confidence and certainty that you're performing well are direct readouts of the evidence supporting particular decisions or actions, versus people who take a more post-decisional constructivist view, saying that evidence is important, but it's not the whole story, that you actually have some kind of model of how you're performing. That model may be more or less accurate. And I think that it's interesting how that actually parallels some of the debates you just mentioned. And so that second order model was proposing that this is one way of thinking about those more post-hoc constructivist computations in metacognition.
Yeah, so I saw this parallel and I found it really interesting because on one hand, Patrick has this idea of free will, in the sense that you could kind of stop yourself from doing something right after you've intended to do it, or you've decided you want to do it, and then you can kind of, whoa, okay, maybe I shouldn't, right? And then there's this same kind of system with metacognition where at the start you have a cognitive process, let's say, and then you have a separate, under the second order model, you have a separate confidence value, let's say. I can't remember the exact term that you used, but yeah, you generate an amount of confidence that you have in that decision, and then it kind of feeds in as like a post-hoc thought. So yeah, I just thought it was interesting to see the relationship between that. Yeah. Okay, so let's get off the air, let's say, and talk about neuroscience for a bit. So I'm curious to know what exactly are the brain regions associated with metacognition, and then I'll get to Patrick about volition and see if there are any overlaps. Yeah.
So I guess a lot of the neuroimaging work with metacognition, say fMRI, uses these kind of confidence-based tasks. So you do usually visual tasks, something really simple. You ask people to say whether they're confident or whether they guess something along those lines. And then what you end up with typically is sensory areas related to the choice that you're making, so visual tasks, visual vision. And then you tend to get a range of frontal regions, kind of give or take, but IFG, MFGs, kind of regions that seem to show up in a huge number, a huge range of tasks in different domains of psychology and neuroscience. That, in my opinion, is just reflecting report. So you've got some internal state, you need to transform it somehow to something reportable to the experimenter. Maybe you need to place it onto a scale, something like this, and that's why they keep it. But it tends to be this, that the first order task represented in the sensory areas, like the sensory motor areas, and then focus.
Anything to add?
Well, yeah, no, I agree with that general characterization. I think that what's an interesting challenge in the field of metacognition research to try and decompose those different components that Maxine just mentioned. So one thing we've been trying to do the past few years in my group is to see if we can design new tasks where we pull apart, say, the confidence signal that you're getting in these perceptual or memory tasks from the need to report it, or some other experimental manipulation that can change the report but keep the confidence constant, and also perhaps even change the source of evidence that is going into that confidence computation. And when we do that, we do start to see dissociations between the involvement of different prefrontal regions. So one quite consistent finding is that you get, in the medial prefrontal cortex, you get signals of confidence in your actions that seem to be relatively automatic. They appear early in the trial, so as soon as you made a response, you get these signatures of confidence in medial prefrontal cortex, and they are. My guess is they're probably quite implicit, that they happen regardless of whether you're asked about them or not. Whereas there are areas on the lateral surface, particularly in the frontopolar cortex, which are particularly active when you're asked to explicitly reflect on your decisions and actions and then communicate those self-assessments to the experimenter. So we can start to dissociate the contributions of different subregions of prefrontal cortex, but it's still very coarse grained. We're still talking about the activity of an entire region of the brain, and I think one challenge is to try and get down to the level of what are these neural circuits actually doing for the system. And I think for metacognition, we're still only scratching the surface on that.
Do you see, what kind of progress do you see in the next 5 years regarding this?
I think that applying the tools of that are now available in cognitive neuroscience to do more fine-grained analyses of brain imaging data are really exciting. So rather than just looking at the univariate activity in a particular area, looking at how the pattern of activity maps onto particular variables in your experiment. So to give you one example, we were interested a few years ago in whether the metacognitive signals we saw in our tasks were shared or distinct between two different tasks. And the way we can start answering that is by training a machine learning classifier to distinguish high and low confidence in task 1, and then ask whether the parts of the brain that can distinguish high and low confidence in task 2 would also then distinguish high and low confidence in the second task. And we found that in this medial prefrontal area we could do that. So that suggests a relatively generic confidence code, but in the lateral prefrontal cortex we couldn't do it. So that suggests a more specific or task-dependent representation. So I think applying those kind of tools is the way we can start to gain slightly more precision in how we understand what those brain regions do.
Patrick, what about you?
Well, it's pretty different in the case of action. And so one of the hardest things about studying action, particularly voluntary actions, is you can't use the classic black box paradigms of the mind, which I kind of think of as going back to Pavlov stimulus response psychology. So the sort of easiest way to study the mind is to think about the mind as a black box, and to have a stimulus which represents the input to the black box, and to measure the behavioral response, which is the output of the black box. And by looking at the relationship between different stimuli and different responses, you can try to work out what's going on in the black box. So that works fine as a way of understanding the mind and or the brain. But if you're trying to study voluntary actions, the key or a key element of the definition of a voluntary action is that the action is not just a direct, immediate response to a stimulus. It's not a reflex. It's voluntary. It's up to you. You decided to do it. Nobody told you to do it. You decided to do it. And therefore, what you're looking for is an internal cause. You're not saying that the action is caused by the stimulus. You're saying it's internally caused. And then the only real way that you can get at the mechanism, you can't use this sort of manipulate the input and measure the output. You can't do that because you don't have access to the input. You're trying to find the input. The only real thing you can do is you can take a reverse engineering approach. The reverse engineering approach says, well, what caused this? So that this is the action. So, the lights go on. So, why did the lights go on? Well, the lights went on because Patrick's finger was on the light switch. And why was Patrick's finger on the light switch? Because his muscles had contracted to move his arm into that location. And why did his muscles contract? And here you can keep following the causal chain back up from the body into the brain. So the reason why my muscles contracted was because the motor neurons in the spinal cord had fired. And why did they fire? They fired because the neurons in the primary motor cortex in the opposite hemisphere had fired and had sent a bunch of action potentials out of the brain down into the spinal cord. Why did the neurons in the primary motor cortex fire? Well, because some neurons in the premotor areas just in front fired, and you can keep trying to chase back this causal chain. And you can get a little bit along, you can get somewhere that way. So you can get a few synapses ahead of the primary motor cortex. So a really sort of beautiful physiological idea, which we owe to Sherrington, is the idea that every voluntary behavior that you do all has to go through the primary motor cortex. The primary motor cortex is the only brain area which can directly control muscles. So it's like a bottleneck. And really all of our cognition, all of our thought, and all of our mental life is focused on trying to get our primary motor cortex to produce the right behaviors by sending motor commands to the muscles. So it all goes out through this primary motor cortex. But as you go sort of reverse engineering back and upstream from the primary motor cortex, you can get a few areas earlier on in the causal chain, and then it gets very complicated very quickly. And it turns out that there's no little man in the head in the frontal lobes sort of pulling the strings to make each successive brain area in the frontal lobe fire. There's no uncaused cause. There's no prime mover. There's no secret in the machine. There's no ghost in the machine. And the causal chain is not so much a chain, but a loop. And here is where we need to think about, not just about the cortex, but about the subcortical structures, and particularly the basal ganglia. So this massive, important input from the subcortical basal ganglia loops back up to the frontal lobes, which seems to be a sort of an iterative loop, which somehow makes what I do now a good thing to do in the context of what has happened before and in the context of what is going on everywhere else in the brain. So you want to think about an adaptive filter which integrates all of the possible information that the brain has access to, not just instantaneously, but previously, and produces a set of adjustments, I think, to the structures in the prefrontal cortex, which allow, through a set of complex rules, that's good. And then you make an action.
The door closed. Oh, I think the door wasn't closed properly, that's why. Yeah, it was the door. Scary.
Right, thank you. So, as I was saying, the subcortical loop through the basal ganglia provides a drive which gets mapped to a set of rules in the frontal cortex. This cascades back into the primary motor cortex, and then the command leaves the brain and goes to the muscle. So we know a little bit about this, this set of loops and this cascade process.
Is there a proportion of brain activity between these areas, or is one heavily, significantly more active than the other?
Well, they're all active all of the time, I would say. Activation's not super helpful because a lot of them are actually, so from the brain's point of view, excitation and inhibition are pretty interchangeable, and you just need one neuron to transform action potentials, increases in action potentials to reductions in action potentials. And the basal ganglia are actually tonically active, so the subcortical structures tend to be firing all the time, and then it's actually a reduction in firing which happens when you move. So there's a quite complex interplay of activation between the cortex, where firing rates are typically quite low, and the subcortical structures where they're typically quite high. I don't think it would be easy to say what's really important. I think that the anatomical mark that I'd want to perhaps leave with people, because it's not much understood in psychology, even though it should be, is that it all has to go through your primary motor cortex in the end. So, psychology, people say it's a study of behavior. Fine. It's actually the study of the output of the primary motor cortex. Because all your behaviours, or anything that a psychologist considers behaviour, all comes out through that crucial link.
Can I ask a question?
Yeah.
So, earlier you were talking about black box and basically scanning during scanning voluntary
Yeah.
behaviour.
Yeah.
So, where do you think there's a role in agency research for looking at how you actually choose your actions? So, for me to make a voluntary action, I need to actually select what I need to do to get me to some sort of goal. So, if you ask people to press a button whenever they want, for example, it's not systematic, but they're making the decision somehow. So, some people, I want to get through this experiment as quickly as possible without the experiment noticing. So they're making some sort of choice to get to some sort of outcome that's desirable. So do you see that as directly agency research?
Well, it's research on action, and it's research. I mean, it's a quite interesting phrase which is used in the literature where people talk about internally generated actions. So if I say, please press this button, but any time you feel like, it's up to you when you do it. I'm not going to tell you to do it now. You choose when you do it. Then what you're really doing is you're allowing people to internally generate the when, but not the what part of the action. So that's an example of something which in fact is generally the case for most of our actions, which is that there's a little bit of environment and stimulus context which helps to guide and funnel our action. And then there's quite a lot that we bring to it ourselves and we generate internally. So the example that comes to mind is comes to my mind is if you go to the supermarket, you want something really simple, like you want to buy some milk, and you go to the supermarket and there's full fat and there's half fat and there's organic and there's different, and you just think, oh, I just want some milk. But you have to generate a decision which bottle of milk you're actually going to reach for, and even once you've decided that you just want the simple semi-skimmed one, there's a row of 10 different bottles which all look exactly identical, but you still got to generate the bit of information in your brain that you're going to get for that one rather than that one. It may not have any consequence because all the bottles should be pretty much identical, but you still got to generate that information, otherwise you won't get any milk. So in most contexts, in most situations, our actions depend a little bit, or to some extent, to some variable extent, on the information that's already present in our stimulus environment, and a little bit on things like our current goals, which are inside us. And mostly it's a hybrid. Now the trouble is that the bit that's inside us is hard to study.
Yeah.
So when you do an experiment, you are taught from 101, if you're doing a psychology degree, that rigorous control of the experimental situation is absolutely crucial, and you have to exactly create the stimulus with high quality and make sure the person's looking at the stimulus and not looking at their phone, which is what most of the participants in my experiment seem to be doing these days. So you have to control the experimental situation. And as a result, I think we often miss this idea that people are internally generating actions all of the time, and that they're making up their own minds about what they're going to do.
Yeah, absolutely. I was just,
Good
yes,
question.
and I was thinking that figuring out what your goals actually are. So I just want some milk is actually a really hard one to get to, because you've got to figure out the best way to get yourself to having some milk, even with there are these choices. So it ends up being really frustrating to solve as a problem. How do I get this in? How do I make my decisions quickly?
How do I implement my decision?
Yeah, and which milk do I choose?
Which
such
milk do I
that my
choose?
task is easy, because
Yeah.
yeah,
There's an argument about how easy it needs to be. So people sometimes say that maybe the cost function is pretty shallow. But anyway, yeah, I agree.
Yeah, I know. It's a really interesting part. Peripheral to agency, directly how to choose the actions that get you.
I said that part of agency is this experience that I did that. And a lot of that is based on the fact that what we think we're doing normally matches with what happens. So if I think, oh, I'm going to go for that milk there because it's the brand I recognise and it's the nearest. And if I find that, in fact, I end up with a different product in my hand, or my hand's in a different place, or I've picked up whiskey rather than milk or whatever, then you have this interesting sort of experience of non-agency. Oh, that's not what happened. You quite often, we had the light switch example, you quite often get this in a house with a staircase and a two-way light switch, where you've got one light switch at the top of the stairs and one light switch at the bottom of the stairs, and you're reaching for the light and it comes on just before you actually press the button because your friend at the top of the stairs has pressed the light switch slightly before you did, and that produces this sort of interesting double take sort of experience where you realize that what's happened is not quite what you thought would happen, and you get this sort of surprise of non-agency.
Okay, so I want to raise another parallel to you guys to see if we can work out this common ground. So, Patrick, you have some work that talks about how the brain binds the temporal, the time in which an action occurs and the time in which we've intended to do something in our heads, right? And from what I understood with the paper, and you can explain it later on, but what I understood is that the brain kind of shifts the two timings closer to each other, so that it seems like we intended to do something a lot closer to when it actually happened. And the parallel I see with this is actually metacognition research, because we have this ability to mind read, right, and mentalize what other people are intending. And so somehow we have to be able to merge other people's actions with what we think they are doing. So it's kind of a bit of theory of mind at play here. So I was just wondering, maybe just as a start, could you explain what mind reading is, what it's like, what the research says about that, and then I'll get Patrick to talk about the other thing, and then see if there any. Mind reading, yeah.
So, I think the way that quite a lot of people think about it now is that you are making an inference about the mental state of another. So, what is that person thinking, or do they understand things? And that it's an inference process, just like how we have to infer visual world, things like that. It's much harder because the information we have is more fresh. We're not actually in the other. And I think something that's interesting that more people are thinking about is how related to metacognition this process is. So in metacognition, where you can frame it in terms of inferences on our own internal states, our own mental states. What am I thinking? Am I good at the start? Blah, blah, blah. And that intuitively that's the same thing as saying, what does this other person do? Does that other person understand what I'm doing? So yeah, but beyond that.
You give anything to that?
Yeah, no, I agree with the way Maxine described the symmetry there, and I think it's very interesting that there is potentially quite a deep computational symmetry between inferring someone else's mental states and inferring what your current thoughts or feelings are about a problem, for instance. And there has been there's a long-standing tradition in philosophy of mind to think about theory of mind and metacognition as being somehow the same thing, but it's surprisingly hard to do experiments that directly contrast these two, because part of the issue is that we have paradigms that have been developed for studying theory of mind, things like the false belief task and classic paradigms used in child development to look at the age at which kids acquire the ability to represent other people's mental states. But those are very different tasks to the kind of tasks we've been talking about that measure metacognition. So far, that linkage has mainly been looked at by comparing these two sets of tasks and looking for things like correlations between performance in the two tasks. And they are there, and especially in the study of child development, there's interesting parallels with the age at which kids acquire robust theory of mind abilities is a similar age, around the age of 4 or 5, that they start acquiring secure metacognitive abilities. And there's been a couple of recent studies from David Williams' lab, working with Peter Carruthers, the philosopher who's kind of put forward this idea very strongly, showing that if you actually get people to do a metacognition task and then get them to perform in parallel a theory of mind task, then that is particularly detrimental to your performance on the metacognition task. But a similarly demanding cognitive task doesn't interfere as much. So there's some kind of interference between thinking about others and thinking about yourself that I think is really interesting, but so far there haven't really been the tools available. I think this is a really interesting challenge for the future, how to properly compare metacognition and theory of mind on an equal footing.
Can I? Because you're going to be on topic.
I was just going to say quickly, I wonder how necessary it is for somebody who's good at metacognition to also be good at theory of mind. So I think it's one thing to say that the processes or computations underlying them might be the same, which is great because now you don't need 2 separate systems to explain something, which is much more satisfying. But because the object of the inference is really different, I think it would be fine for them to dissociate as well. So you're doing metacognitive evaluation about something, and your expertise in that thing varies, and your knowledge about it varies, so your metacognitive performance might vary, and that's fine. And then likewise, the way in which I understand somebody that I don't know well versus maybe a family member is going to be completely different. The extent to which the person I'm trying to understand is similar to me is going to have a huge effect because it's reasonable for me to just use my knowledge about myself. So yeah, it's just, I wonder whether they even need to correlate.
Well,
It's quite a tough ask.
Yeah, so and I think this is part of the problem with the very different paradigms in use here, is they might not correlate, but not because they're not tapping into a common process, but it's the content of the task that is just very different. We did a brain imaging experiment a couple of years ago trying to look at this, where we set up a paradigm where the subject was either judging their own confidence in their task performance, or they were judging their confidence in someone else's task performance, to try to get this self and other inference to be comparable. And one hypothesis we had going into that study is that we would see very similar brain networks involved. And actually we saw very different networks involved. We saw more of the classical social cognition, theory of mind type network involved in the judging the other player, but judging yourself, we found the reasons we were talking about earlier, confidence signals in the prefrontal cortex and so on. So, and I think what we realized when we were writing up that paper is that in this particular setting, there are big differences, but that's not necessarily because there isn't a common process involved. It's just that when you're judging yourself, you have much more evidence. You don't need to learn about yourself in the same way that you're learning about someone else. So I think there are dissociations that might be coming not from the fact there isn't a common process. There might well be. It's just we haven't got the paradigms to really expose it.
I wanted to try maybe a different way of thinking about theory of mind, which is a sort of motor biased way that really a very important part of theory of mind is that you're trying to reverse engineer somebody else's motor system, right? So you're asking, well, why did she do that? I mean, why on earth did she do that? I cannot imagine why she switched on the light or pulled the trigger or whatever it was she did. So at that point, it seems more like you're perhaps trying to simulate the processes that you use in your own goal-directed action to try to recover the causes of somebody else's non-obvious behaviors, right? So you're trying to understand their motives and their goals. And that doesn't necessarily seem metacognitive. That just seems like a kind of causal inference.
What are your thoughts on the idea that we essentially do the same thing for ourselves in the same way? So, well, you could think of it as a theory of mind, but for my own mind. Yeah, and which is why I brought up your work on binding, because I thought it was so interesting that we have this association within ourselves.
Yeah, so yeah, it's difficult. It's difficult to see what sort of experimental evidence would show us that that's how we understand ourselves. That's a pretty deep question about self-consciousness, which is it's not the kind of thing you can capture in a lab experiment, I think. So you mentioned binding. So I make a distinction between, right now I'm going to use the word intention and agency. So intention is what happens before you move, and it's related to goals. So intention is normally the way that you answer why questions. So, you know, why did you switch? Why did you reach out? Because I was trying to switch the lights on. In theory of mind, what you're trying to do is you're trying to recover the potential intentions of other people. There's a really interesting question about whether you need to recover your own intentions by simulation or by some other process, or do you have direct access to your own intentions? Do you always know what your intentions are? And that's something that Freud in particular had a lot to say about. But intention is all about what happens before you move. And agency is all about how you understand what happens after you move. So agency is about the fact that you make the movement and you feel, oh yeah, I did that, it's my movement. I made the movement, the lights came on. So it's about the experience of what happens. Whereas intention is about what might happen or what's about to happen or what's going to happen in the future. So the two, if you have a timeline, then intention is at the early part of the timeline. There's this critical point, let me plug it again, where the motor command leaves the primary motor cortex and goes down to the spinal cord into the muscles, where thought gets transformed into physical, objective movements of the body. That's a critical event. And it's the dividing line between the sort of the actions that I will make and the actions that I'm really making, and the sort of agentic regime where you're dealing with that. So you mentioned binding, or temporal binding or intentional binding. So intentional binding is just a measurement. It's just an effect. It's just an observation. It's not a theory. It's an observation. But it happens to be a useful way to study the sense of agency. So when people make an action which produces an external outcome, if you have an experiment where, for example, people press a button and the light comes on, you can ask them, when do you think you pressed the button? And they normally report the position of a clock, which their hand, which is rotating round and round. Or you can ask them, when do you think the lights came on? So you can ask people to report, to make subjective judgments about time perception for their own action and for the external consequences of the action. And what you find is that people perceive the time of their own action to be shifted towards the outcome that the action produces, like the lights going on, and they perceive the outcome that they've produced, the lights going on, as happening closer to the time of their key press than it really did. So in reality, you know, we do something and then after a delay it has a consequence. But in our mental lives, we perceive the action and the consequence as being bound together, as happening in close succession. So the Scottish philosopher David Hume, 250 years ago, would have said, I told you so. And would say, this is not surprising. This is the constant conjunction of events. This is the temporal contiguity. And this is the association between cause and effect. And it just happens to be a nice psychological measurement. It happens to be an easy thing to study. It happens to be a kind of an informative measure of how the mind computes the relationship between what I do and what happens afterwards as a result. So it gives us a window into this experience of sense of agency, which is just experimentally very convenient, largely because it's implicit. So I mentioned explicit judgments of agency. Did you do that? Did you do that? Did I do that? Did she do that? So there's a really good reason why you shouldn't ask explicit judgments of agency in experimental psychology. And you'll have seen this if you do group projects. So you probably do group experimental labs. for research methods. So you know what happens is you have to do the experiment, you have to collect all the data, you have to enter the data, and then you submit the report, and then you get a grade, right? So if you ask, if the grade's really good, then people are really happy to say, well, I did that, you know, it was my data which got us all an A on that project. Whereas if the whole thing's a complete disaster, and I don't know, none of the equipment worked, and you know, all of the reaction times were negative, or something else went really badly wrong, and of course it's not my fault. It was somebody else. So the way that we explicitly accept or reject agency is deeply, deeply colored by desirability. So nobody wants to admit to something which has gone wrong, right? Whereas everybody wants to take credit when it goes right. But if you just ask people, when did you press the button? When did the light come on? When did this happen? When did that happen? If you ask about the temporal features of people's experiences, I think people can't do that. They can't filter all of their judgments and all of their experiences through this kind of cognitive dissonance filter to make themselves look good. You just ask a really simple question so that a person who maybe has an ulterior motive or has a particular thing they're trying to get out of the experiment doesn't know how to cheat. And that is a really good principle of experimental design, is to try to design an experiment where even a participant who wants to cheat can't or doesn't easily see how. So temporal binding is just a measure which is a quite good way of talking about sense of agency experimentally. It's a convenient implicit proxy for sense of agency based on time perception, and it just happens to have, I think, proved relatively useful for studying this experience of, I did that. That's all.
Well, I mean, this whole concept is really interesting to me because, and tell me what you think about this, because as I read about how the brain does sort of predictive work, right? It constructs things based on its best guess of what is out there in the world, sort of the Bayesian approach, essentially, right? I see echoes of it in this kind of system because it's almost as if the brain is kind of making its best guess for our intention compared to what we actually did in the world. Yeah. Am I making any sense? Yeah. Okay. But
I mean, just on that. So I think that one thing that's useful to always keep in mind is that in psychology we have labels for things. We need to carve up the territory to enable experiments to be done on particular aspects of how the mind works. But those boundaries are really our boundaries as experimenters. They're not boundaries that the brain necessarily has. The brain doesn't know what's metacognition and what's not metacognition. The brain doesn't know what's agency and not agency. Basically, these are labels that we're giving to a particular class of phenomena. And I think it is always useful to kind of question whether there is some broader unifying principle that can start to bring this territory into clearer focus. And one unifying principle that is useful to think about is the notion of inference, that we're trying to deal with noisy, limited information. Obviously, this is most well studied in perception, so the notion of perception is some inference about the outside world is increasingly popular. But I think taking that up to higher cognition is an exciting project that is only really just getting going. And one thing I'm struck by in the parallels with how Patrick's describing agency is the notion that I did this, the kind of subjective judgment of control. You can start to see parallels with some of the models in the metacognition literature which are trying to study whether you are confident in performing something well. That's essentially like saying that I did this correctly.
Yeah.
And so there's this. So all of it is in the frame of reference of our own actions on both sides, I think, of this debate or this discussion. And one thing that has been quite helpful in the metacognition literature is to recognize that there's various aspects of metacognition that have attracted their own labels. So people in the memory field talk about judgments of learning, people in the perception field talk about retrospective confidence judgments, and I think people are starting to realise that there might be some common principle there, which is essentially that the system is trying to estimate a degree of belief that the actions it's taking are consistent with the goal of the task, right? And it's trying to do that in the absence of feedback. That's really one of the defining features of metacognition, is that we're not getting told whether we're right or wrong, we're having to figure this out ourselves. And it's all in the frame of reference of our own actions. And I think that's where it starts to be really interesting in terms of the commonalities with inferring whether I did this or not.
It's like, I did that well.
I did that
or
well.
I did that
Exactly.
badly.
Yeah.
Yeah.
Yeah, exactly.
Not just, I did that.
Yes. Yeah.
That's really interesting.
Okay.
These kind of frameworks also end up giving you a lot for free, which is kind of a hallmark of a really nice framework. So say in the comparator models that often get brought in when you're talking about agency. So the idea that these sensory motor couplings, how do I account for the fact that I'm making some sort of action? So you can attenuate the sensory consequences of your own action so that you don't get surprised conceptually.
Yeah.
So for example, if I move, the whole world moves around me, I don't want that to be surprising. And these kind of things get brought into vision and predictive, casting predictive processing. What's really nice is that once you start talking about attenuating the consequences of your own action, you can get some sort of concept of being an agent. Everything related to my actions, I can cancel. And now there's some sort of way of modelling myself. Do you follow what I mean?
Yeah.
Which ends up being quite satisfying. So you don't have to solve the problem. How do I know that I'm an agent? It just comes out of the facts that you're cancelling out.
Could I, like that, I absolutely agree about the power of these sort of predictive models. So I predict that the lights will go on as I click on the light switch. And that's how I compute my agency. So I entirely agree with that. But I think what's interesting is that the computational model suggests that, you attenuate or you suppress or you cancel signals that you can predict are going to happen. So it's almost like you would have a sense of non-agency. So you would have no signal that the lights have gone on because it's been cancelled from the fact that you predict the lights would go on. And in those models, as I understand it, you're supposed to have a sense of agency when what happens is exactly what you predict will happen. So you subtract the feedback from the prediction, and if it's zero, then what's happened is what you intended to happen, and you're the agent. And that's great. That's computationally very elegant. In terms of phenomenal experience, it doesn't explain why we experience that why outcomes have any sort of positive phenomenal significance at all, because they should have been cancelled, right? So it seems to me to work really well as a computational theory, but what it predicts is that there should be no phenomenology of agency, because the thing that you've controlled has been cancelled from the system, the signal's been subtracted out. And I think it's difficult to explain, for example, I go to a concert, it's predictable action. I predict I'm going to hear Beethoven's Fifth. I don't want to cancel it. I don't want to not hear it. I mean, why would I pay 20 quid to predict that I'm going to hear this fantastic music, and then because I know that I've somehow made it happen, and it's also ridiculous because we do perceive the consequences of our own actions, and we often perform actions because we want the particular sensory pleasure, perhaps, of them. So I've always found it tricky to balance the computational rigor of those paradigms with the sort of phenomenal aspect of agency, and particularly the fact that we generally choose to do things because we like the outcome and we want the sensory experience of the outcome.
I mean, I'm definitely not wedded to it as a model of agency, but just as a model of sensory coupling. But I don't think it needs to be the case that agency is a positive signal.
Okay.
It doesn't necessarily. So I don't think it needs to be the case that for a model to predict that you've got some phenomenology for something, there has to be a positive
A signal?
number.
No, okay, all right.
Because say on predictive coding, you want to be able to explain the world. So what low signals,
Yeah.
you're definitely seeing things. So I don't know.
But it feels like
That's
this.
it
So
feels
then-
necessary.
Then the seeing is fine, but it's not as a separate model from predictive coding, so you need a separate.
Well, I think there's two questions here. So one is Bayesian predictive accounts of the brain, are they right or wrong? Like, is it a useful model of how systems work or not? And it feels like it's a good model so far, and maybe there will be refinements and so on down the line. But the second question, which I think is distinct, which is perhaps the one you're debating, is how do the aspects of that computational account map onto subjective experience?
Right, exactly.
And that seems to be much more under constrained. Is in the one way of accounting for why you still hear and enjoy the Beethoven is that your subjective experience is actually tracking not the prediction error, but the model you have of the world right now, which has been updated by all these different things. So it does, and that to me seems like still quite an open question. How do we best map across from these computational accounts to aspects of subjective experience?
And there's no reason to say that when it goes according to your prediction that you don't experience any phenomenology of that. Right?
I suppose maybe my argument only works if you make the foolish assumption that phenomenology corresponds to signal, which is what you were saying.
Although the sensory attenuation idea would say that there is some genuine attenuation. I know, for instance, Claire Press, who's also here at UCL, this is a lot of her research program is trying to understand whether the attenuation ideas really do map onto phenomenology or not. I know her recent work is questioning that in the domain of action.
Okay, so I want to leave some time for Q&A, so I won't dwell too much on the very last question. But this question pivots more to the clinical side of this discussion. Because again, I'm in my second year now, so we're going through like disorders, especially for things like depression and anxiety. And something I noticed is that, especially for those kinds of disorders, distinguishing between an external and internal cause of a problem is extremely important, right? Because if you think that something is your fault when it really isn't, then that seems like an error that you create that would cause an eventual disorder. So, what are your thoughts on kind of clinical benefits of understanding metacognition better and provision?
I think that it's still, metacognition is still quite a young field, relatively speaking. And even though intuitively there's a lot that you could say about how understanding metacognition is going to be really important, I'm not sure it's quite ready to make really strong claims. So a really thorough computation science and neuroscience and metacognition is not quite there yet. But in principle, understanding how it is that we do things like form self-efficacy judgments or beliefs about how good we are at things and how capable we are, how we decide what's plausible for us to achieve versus implausible, given our strengths and weaknesses, is really important. But I don't know how much it can do yet.
Yeah, I mean, it's something that we've tried to pursue in our lab is more applied side of thinking about how changes in metacognition might be contributing to some of the psychiatric symptoms that you described. I think that one direction that this can be perceived as Maxine says, looking at these higher, more abstract levels of self-evaluation, what in the literature we sometimes call more global judgments. So rather than just evaluating individual decisions or actions, looking at how we build up beliefs about ourselves that unfold over longer timescales. And that's quite a productive research program, because you can then start studying how these beliefs that are formed over longer timescales are informed by metacognitive states that unfold over faster timescales, so the kind of things we can study in the lab. And there I think then you are tapping into the types of self-belief that are relevant for conditions such as depression and anxiety, so people thinking that they are unable to succeed at anything, that's a self-evaluation that decouples from the reality of their skills and abilities. So I think that there's been quite a bit of work on this now, showing that does indeed map onto symptoms, clinical symptoms. But I also agree with Maxine that just doing that kind of work is not necessarily going to help people, and I think that's the real issue. Actually, for a lot of computational psychiatry, that's the real issue. We're doing a lot of interesting work, none of it really so far has helped.
Yeah, because from my perspective, CBT, cognitive behavior therapy, seems to me like an external kind of metacognition. I don't really follow here, but it's something like someone else acting as your metacognition for you.
Yeah.
And so it seems like you can train somebody to, I don't know, CBT themselves maybe.
I mean, using, I think that's a really nice way of putting it. And, I mean, the ability to now use tools like large language models to essentially discuss with another external system that is quite sophisticated and can integrate everything you're throwing at it and feed that back to you is really powerful. I found it very useful in just thinking about new directions, thinking about grants, experiments, and so on. Systems like ChatGPT are phenomenally helpful because they essentially act as a little external resource that can evaluate and repackage what you're saying. So I do think that's quite an exciting direction to go.
Not really. Lots of different psychopathological conditions involve some sort of abnormality of agency. So schizophrenia psychosis is the most obvious one, where there's often direct florids of misunderstanding of agency. So I don't know, a patient might experience that somebody else is controlling their thoughts and their actions. And so clearly a pathology of agency. Depression, I can't get out of bed, I can't be bothered, I can't do anything, loss of self-efficacy. You're never going to feel I did that if you've got severe depression. You just can't make anything happen. So that's a pathology of agency. And this is quite useful practice because I've volunteered to give a talk later in the month to a bunch of neuropsychologists and neurologists. And in neurology, you always think about movement disorders as hyperkinetic or hypokinetic. So either you're moving too much or you're not moving enough. That's the sort of axis of how much movement there is. And I suppose the implicit assumption is there's some sort of sweet spot in the middle where you're just making the right amount of movement and everything's fine. That would be healthy. That would be being healthy. And I think there's a psychological axis which is orthogonal to that, which is not so much how much you move, but how your movements relate to yourself. So it would be your capacity for volition and your sense of agency. So are your movements really the ones that you want? And it's interesting that in this sort of subjective hypovolition, hypervolition, you get both poles. You can either be too voluntary, you can be sort of impulsive and always doing stuff, and you drive your friends completely mad, drive everybody mad. Or you can be insufficiently voluntary. You can be too passive. You can be, unable to initiate anything, and probably that's not great either. So there's going to be a lot of other stuff. There are going to be social norms. There's going to be conditioning, but there's somehow a feeling that there's a right level of volition, which is good. It's going to be contextually dependent, and you get interesting ways of thinking about, for example, learned helplessness, which is a good model of clinical depression. There's no volition. The animal doesn't even try to escape, even if it can. So that's a good model of hypovolition. So I think really a lot of what one's trying to do into understanding and even more treating mental health conditions is you're trying to restore some sense of the person having voluntary capacity over their own actions and their own life.